Hi everybody, in this video we're solving a normal distribution application problem using Minitab. Our problem says the setting time of a particular concrete mix is normally distributed with a mean of 8 hours and a standard deviation of 0.8 hours. We're going to answer all probability questions as percentages rounded to 2 decimal places. In part A, we'll find the probability that the concrete will set in less than 8.6 hours. In part B, we'll find the probability that the concrete will require more than 10 hours to set. Part C asks for the probability that the concrete will set between 5 and 10 hours. Then part D says if 300 concrete batches are produced using this mix, how many would be expected to set between 5 and 10 hours? And in this case, we're not given a percent, we are rounding up to the nearest whole number. To answer all of these questions, we're going to go over to Minitab. There are a couple of different ways we could go about getting these answers, but I like the visual graph to go along with the answers, so in each case I'm going to go to graph. Then I'll go to probability distribution plot and view probability. By default, it's going to come to the normal distribution, but we have to put in the mean and the standard deviation. We were given a mean of 8, and we had a standard deviation of 0.8. Our first case says find the probability that the setting time was less than 8.6 hours. So that's a specified x value. Less than is left, and we'll put in our value of 8.6. This tells us the probability is 0.7734, so we'll enter 77.34, and that's a percentage. In part B, we're looking at the probability it takes more than 10 hours. So back to graph, probability distribution plot, view probability. Our mean and standard deviation stay the same, but on the options now, because I'm doing greater than, I'm going to go to the right, and then we'll put in an x value of 10. In this graph, we can see our shading is over to the right. It's really small. It says 0.006210. Remember, we're going to take this from being a decimal, make it a percent, which is 0.62. Now we want to look at the probability it takes between 5 and 10 hours. So back to graph, probability distribution plot, view probability. In the options, we want to pick middle, and we're going from 5 to 10. Here we see most of the curve is shaded, and our decimal of 0.9937 gives us a probability of 99.37%. Part D is related to our answer in C. C looked at 5 to 10 hours, and so does D. So we're taking this 99.37% and we're applying it to 300 concrete batches. So in the calculator, I'll put 0.9937 times 300, which says 298.11. The directions say round this up to the nearest whole number, so rounding this up takes it to 299. Remember, it doesn't say round, it says round up. So I'll enter my 299, check my answers, and see that I got all parts correct.